Hey, this is the last section of Chapter 3 in Algebra 1A. It is arithmetic sequences, and it looks like the word arithmetic, and it is also pronounced that way in a different setting. But an arithmetic sequence is basically just a sequence in which we use addition to get to the next term. So addition is like doing arithmetic, so that's why we call it an arithmetic sequence. Okay, so first of all, let's talk about the definition of a sequence. Okay, so a sequence is a list of numbers that usually forms a pattern, okay? Each number is a term. So in this sequence here, the numbers are 3, 5, 7, 9, and it continues. The first term is 3, the second term is 5, the third term is 7, fourth term is 9, etc. If you see dots, that means that the sequence goes on forever or it's infinite. Okay? All right, when the terms of a sequence differ by the same non-zero number d, we're going to call d the common difference. Okay? D is the common difference. That is an arithmetic sequence. So like I said, if we keep adding the same number over and over to get the next number, that's arithmetic. So in this case, we're adding 2 every single time, and that would be our common difference. Okay, the difference between the two numbers, if I were to subtract them, that's what I mean by difference. Difference means subtract. 5 minus 3 is 2, so that's how I get from one number to the next. Okay, here's another example. During a thunderstorm, you can estimate your distance from a lightning strike by counting the number of seconds from the time you see the lightning until you hear the thunder. So after 1 second, if you see the lightning strike and then you hear the thunder 1 second later, that storm is 0.2 miles away. If you, for example, count 4 seconds between lightning and thunder, it's 0.8 miles away. Okay, notice what's happening here every single time is the distance is increasing by 0.2 every single time. So the common difference is 0.2. This is an arithmetic sequence, these numbers right here, because they are increasing by the same number every time. Okay, so this next part says determine whether the sequence appears to be an arithmetic sequence. If so, find the common difference in the next three terms. Okay, so if I take a look here, we've got 9, 13, 17, 21. So to get from 9 to 13, I would add 4. What about from 13 to 17? Well, I could add 4. And from 17 to 21, I would add 4. So I'm going to say, yes, this does appear to be arithmetic. Okay, and then the common difference is that number that we keep adding every single time. So D is equal to 4. Now we're also looking for the next three terms. So if I were to add 4 to 21, I would get 25. Add 4 again, I get 29. Add 4 again, I get 33. Okay, the next one starts with the number 14, and then we go down to 5. So we're really subtracting 9. What about 5 to negative 4? Well, that's subtraction of 9. And 4 to negative 13 is also subtraction of 9. Okay, that is going to be arithmetic because we can think of subtraction as adding a negative 9. So here our sequence is going to be arithmetic. Our common difference is going to be a negative 9 because we could think of this as adding a negative 9 every time. And then the next three terms, well, if I were to subtract 9 from negative 13, I would get negative 22. If I subtract 9 from that, I get negative 31. And if I subtract 9 there, I'll get negative 40. Okay, the next one is 10, 8, 5, 1. To get from 10 to 8, I would subtract 2. From 8 to 5, I would subtract 3. And then 5 to 1, I would subtract 4. Since these are all the same, not the same numbers, this is going to be not arithmetic. It's still a sequence because there is a pattern going on, but it's not an arithmetic one. Okay. All right. With this one, with fractions, if you do not really understand how to find the difference between them, you can use a calculator to subtract every time. So if we take the second term minus the first term, that will tell us what our common difference is. So if I were to go into Desmos here, and our second term was negative 1/4, and then I'm going to subtract the first term, which was a negative 3/4. Oops. That ends up being 0.5 or 1/2. Okay, so to get from here to here, since it's positive, we are adding half. Okay, now I can do the same thing from 1/4 to negative 1/4 to see what's going on there. So I'll take the third term and subtract the second term, and that also ends up being 0.5 or 1/2. So here, from here to here, we are also adding half. Okay, and then I'm going to do it from the last term to the third term. So 3/4 minus the term that comes before that, which was 1/4, is again 0.5 or 1/2. So here again, we are adding half. Now the reason I'm using a fraction is because the problem had a fraction, which means that I should probably stick with fraction form. Okay, since we're adding the same number every time, this is an arithmetic sequence. Our common difference is 1/2. And now I need to come up with the next three terms. So you can use Desmos to do this, but 3/4 plus 1/2 is 5/4. And then 5/4 plus 1/2 is 7/4. And then 7/4 plus 1/2 is going to be 9/4. Okay. Okay, so the next part says to find the nth term of an arithmetic sequence. When n is a large number, we need a rule. So for example, if I wanted to know back in, like, for example, this first pattern, if I wanted to know like the 25th number in this sequence, I could write it out to find out the 25th number, but that's a lot of work. So there's actually a formula that we can use that will help us with that. Okay, so look for a pattern to find a rule to the sequence below. So for example, this one, 3, 5, 7, 9, we need to know what the sequence starts with. Okay, so notice you're going to see these numbers down here, a sub 1, a sub 2, a sub 3. This is which term it is. So a sub 1 means the first term is 3. A sub 2 means the second term is 5. A sub 3 means the third term is 7. A sub 4 means the fourth term is 9, and we use this a sub n for like any term, okay? So we need to know a sub 1, or the first term for each sequence, to be able to write an equation, and the common difference. So the common difference is the number we're adding every time, which is 2. So we can write a rule. Okay, so here the first term is 3. For the second term, we take 3, and then we add the common difference once, which is 5. Then the second time we start with 3 and we add the common difference 2 twice. So we end up getting 7. For the next term, we again start the sequence with 3 and we add this common difference 3 times to get 9, and so on. So it turns out to be that we have this formula here that we are going to be using to come up with our equation to find any term. Okay, so this is very important to understand what all the variables mean. So again, a sub n means whichever term you're looking for. A sub 1 is the first term. N is the term number. So if I'm looking for the 6th term, n would be 6. And D is our common difference. Okay, so for example here, it says find the indicated term of the arithmetic sequence. So for that sequence that we just were working with, 3, 5, 7, 9, we want to figure out what is the 20th term without writing it all out. So what we need to do is we need to use this part of the equation. We need to substitute these three variables. So a sub 1, again, is the first term. So the first term in this sequence here is 3, okay? N is going to be the term number. I need that, which we're looking for the 20th term. And then D is the other variable that we need every time we want to rule. And D is our common difference, which in this case we're adding 2 every single time. Okay, so what we're going to do is we're going to substitute here. So a sub n, we're going to do a sub 20, which means the 20th term. Now we're going to replace a sub 1 with 3, and then plus, and then we have our parentheses. Now it's n minus 1, so our n is 20. So we're going to write 20 minus 1, and then it's going to be times the common difference, which is 2. Okay, you can use your own math to help you out with this, or we can enter this into Desmos or a calculator. So it was 3 plus, the parentheses are important, that's why they're there, and then a 2 afterwards. That tells me the answer would be 41. So that's telling me that the 20th term in this sequence would be 41. And I was able to do that without writing out 20 terms and adding 2 over and over and over and over. Okay? So using this formula will help you a great deal. All right, so this one we're looking for the 16th term of this sequence. So we do need to know what number we are adding every single time. So to get from 4 to 8, we're adding 4, 8 to 12, adding 4. Okay, so that means our common difference is 4. Okay, so if we, again, write out all of our variables just like we did here, a sub 1 is the first term, and here our first term is 4, this number right here. Then n is how many terms we're looking for, and it's telling us we want the 16th term, so n is going to be 16. And then finally, d is our common difference, which we figured out is 4, because we're adding 4 every time. Okay, let's use our formula. So a sub n, you don't really have to worry about this part on the left that much. So if you don't even want to write it out, I'm not going to be mad at you. Okay, so a sub 16 means the 16th term. And we're going to start with a sub 1. The first term is 4 plus, and now in parentheses, it's n minus 1, and our n is 16, so it'll be 16 minus 1 times the common difference, which is 4. Okay, if I were to enter all of that into Desmos or on a calculator, I would get 64. So that tells me that the 16th term of this sequence is 64, without even writing it out to 16 different terms. Okay, here's the next one, the 25th term of this. Now this time the numbers aren't given, but they give us the a sub 1 and they give us the d, right? And this 25th term right here, that's the n. So they do give us all the parts of the equation. I don't even have to figure out the common difference. Okay, I'm going to do this little thing and just kind of put a dot next to here so we know that this means multiplication, because that's going to come in handy in this problem. Okay, so a sub 25, we want the 25th term. Again, we're going to start with our first term, which is a negative 5. And then we write plus. Now in parentheses, we're going to do n minus 1, and n is 25. So we're going to do 25 minus 1. And now we're going to multiply by the common difference. So be careful, because if you just write negative 2 outside, it looks like minus 2. So I'm actually going to put parentheses here to put negative 2, so I remember that it is multiplying. So I'm going to go ahead into Desmos and enter that. So it's negative 5 plus 25 minus 1 in parentheses, and then I'm going to write negative 2 in parentheses to show that that's multiplication, and we end up with a negative 53. So the 25th term of that sequence would be a negative 53. You could start with negative 5 and keep subtracting 2 25 times, but that's a lot more work than this. Speaking of which, trying to find the 60th term of this sequence would probably take you at least, probably almost an hour. So let's not do that. Let's use the formula. So in this sequence, first of all, the first thing we should probably do is figure out the common difference. So what's happening every single time? So 11 to 5, we're subtracting 6, right? 5 to minus 1, we're subtracting 6. Here, subtracting 6. So that means my common difference is a negative 6. If we write out all of our variables, the first term is 11. The n, we're looking for the 60th term, so that's my n. And then again, d is negative 6. Okay, so let's substitute in this formula. So I'm going to write a sub 60 because we're looking for the 60th term. The 60th term, we're going to start with a sub 1, which is 11, plus, now in parentheses, it's n minus 1, so 60 minus 1. And then again, our common difference at the end is a negative number, so I'm going to put that in parentheses multiplied by a negative 6, so it doesn't look like a minus 6 at the end. Okay, if I simplify all of that, enter it in on a calculator, I end up with a number negative 343. Okay, that does make sense because this keeps going down and getting more and more negative every term. Okay. So now we're going to have just some kind of applications of that. So a bag of cat food weighs 18 pounds at the beginning of day 1. Each day, the cats are fed a half pound of food. How much does the bag of cat food weigh at the beginning of day 30? So what we've got here is, again, if we were to write out some of the most important parts, we need our a sub 1, we need our n, and we need our common difference, d, right? So the first term is what we're starting with. So here it's starting at 18 pounds, right? N is after how long, or the number of days. So in this case, it's after 30 days. And then the cats are fed a half pound of food. So every day, the amount of food is actually decreasing by half. So our common difference is going to be a negative 0.5. Because every day, like if we start with 18, the next is going to be 17 and a half, right? Because we'd subtract a half pound of food. The next day it would be 17 because we'd subtract another half. So now if I use the formula, we're looking for the 30th term. We start with the first term, which is 18, and then plus, in parentheses, we do n minus 1, so 30 minus 1, and then we multiply by the common difference at the end. And if you put this in on Desmos or another calculator, you end up with 3.5 pounds. Okay, so after 30 days, we're down to 3.5 pounds of cat food. Okay, so the next one says, on day 1, Zella's knitted 61 rows of a scarf. Each day she adds 17 more rows. How many rows total has she knitted on day 1 or day 16? Okay, so on the first day, this is how much she has knitted. So that's actually our first term. That's our a sub 1. Each day she adds 17 more rows. So the number she's adding, that's our common difference. We're adding 17 every day. How many has she knitted on day 16? So after 16 days, where are we at? That's our n. Okay, so we're going to just use our formula. So after 16 days, I want to know how many she's got on day 16. So the 16th term, we always start with a sub 1, which is 61, plus, and then in parentheses, it's n minus 1, so 16 minus 1, times the common difference. In this case, it is a positive 17. Okay, and I'll go ahead and do this one on Desmos. So 61 plus parentheses 16 minus 1 times 17 is 316. So by that last day, the 16th day, she has knitted 316 rows. Okay, please let me know if you have any questions on arithmetic sequences.